A COVID vaccine is coming for you. What should you expect? First, the Pfizer-BioNTech and Moderna vaccines. These are furthest along, and both are mRNA vaccines.
Messenger RNA is a little piece of genetic material. It has the blueprint for creating proteins. And so in this case, what they've done is they've taken the part of the messenger RNA that codes for the little spiky thing on top of the virus. The spike protein is the part of the virus that causes the best immune response. They put it based on a little piece of fat. They inject it in your body. Your machinery makes the spike protein, and then your body recognizes that spike protein as foreign, and it creates an immune response to it and helps destroy viruses.
Now, RNA is fragile and unstable.
It just falls apart in warm temperatures.
Which means these vaccines must be transported at cold temperatures. For Pfizer, that's minus 94 Fahrenheit, and that requires dry ice in the packaging and an entire ultra-cold chain with special freezers all along their journey. In-box digital data loggers track the temperature, so when the box is opened, the user will know if the vaccine ever got too warm, which could make it ineffective.
But it's moving it from a storage bin to a clinic or doctor's office where we only have refrigerators, and we really generally don't have the ability to keep things very, very cold. So part of the challenges is making sure that we get the right number of doses to the right practice at the right time.
The Moderna vaccine is more stable than Pfizer's, so standard refrigeration during transport will do just fine. Both mRNA vaccines will require a double dose, separated by 3 to 4 weeks. For the vaccine to work properly, you need both shots. There are other vaccine contenders in the works, too. If the ones from Johnson & Johnson and Oxford AstraZeneca get approved, they'll require normal refrigeration during transport. They rely on a different approach. Instead of RNA, the vaccines use DNA that codes for the spike protein, which is inserted not into a bubble of fat or lipid, but into a common kind of virus called an adenovirus.
Think of the adenovirus as a delivery virus that actually delivers it into your body's cells. That's non-lethal. That doesn't make you sick. It's just another way of getting it into your body.
Now, it's important to mention that all these vaccines can cause side effects. In trials for the Pfizer and Moderna vaccines, some people reported severe short-term side effects, severe fever in fewer than 2% of participants, but higher numbers for other side effects.
For some people, that first shot puts them down for 24 hours or so. They just feel really terrible.
When we think about communicating the side effects of the COVID vaccine, it is going to be really important to be absolutely transparent.
Well, it's your body's immune response. It tells you that it's working. Your body's sending the antibodies to that spot, and it causes a huge amount of inflammation.
For the mRNA vaccines, it may be that the lipid bubble is what sets off the side effects.
And people are going to have to be encouraged to come back for their second shot so that they're fully protected. Yeah, making a vaccine and then getting shots in the arms are two different things.
Vaccinating the better part of an entire country is a massive logistical undertaking.
We have a foundation of a system that works, but it needs to be amplified and ramped up. We're also introducing the Department of Defense and the military to work in collaboration with this ongoing system, and that has never been tried before.
We also have to be transparent about who is going to get the vaccine first, why, and then how it will be phased out across the other populations.
Millions of people will be prioritized based on risk level and exposure. The first wave of vaccines will likely go to people in long-term care facilities like nursing homes and frontline healthcare workers.
The doctors, the nurses, the MAs, those that we need to provide the necessary care and testing.
Dedicating themselves in such heroic fashion 24/7 to be as healthy as possible so they can keep caring for all of us and get us through this pandemic.
There's another high priority group.
There's a population of people that are at risk, people with chronic diseases, heart disease, lung disease, kidney disease, diabetes.
Some of these conditions are inherited, but for many, they're a result of systemic racial and social inequities.
Particularly in communities of color, African American, Native American, and Latinx individuals. They're much more likely to be exposed to the virus and get sick than non-Hispanic whites.
And so a lot of repair work is going to need to be done to rebuild the trust that these vaccines, these treatments are built on the best science available so that there is vaccine uptake in communities who have been disproportionately impacted by COVID-19. Many of them are very distrustful, and the population I serve, American Indians and Alaska Natives, are not going to take that vaccine because of the extreme hesitancy that exists.
Making this vaccine acceptance effort a high priority is absolutely critical for the future public health of our country.
As the vaccines course through our communities, it's worth stating they're not an instant fix. It's estimated to take 1 to 2 weeks after getting the second shot for your immune system to have produced the antibodies you need to be protected from COVID-19.
No vaccine is 100% effective.
We are going to need to ensure that there are proper public health safety precautions that are also continued, such as masking, such as social distancing, hand washing. All of those things need to be continued to be communicated.
We also don't know yet if any of the vaccines actually stop you from getting infected. So far, we just know that they can prevent people from getting sick. But it's possible that people could still catch the coronavirus and be able to spread it to others, even if they've been vaccinated. The vaccines will take time to roll out, and they haven't even been tested on certain populations yet, like pregnant women and children.
Which is our practice. We do adults first before we put our kids at risk. Their bodies are developing different, their immune systems function differently.
There's a lot we don't yet know about these vaccines, like how long they'll last. But one thing's certain, the fact that we have working vaccines a mere year into this pandemic is a mighty achievement.
So we should think of this as our moonshot in terms of what we've done to try to create vaccines. It's an amazing story, and we should think of it as an amazing